This is Mrs. Boots, and this is a little chant to help you remember your exponent rules. I've written it out for you, so see if you can follow along and make the hand signals with me. When you multiply, you add the powers. When you divide, you subtract the powers. Parentheses to a power, multiply the powers. Negative powers, move to the other side. Power of 0 always equals 1. Rational powers become a radical. With the multiplication of exponents, we actually have two different rules from our table that apply. The first one is when I'm multiplying one term to another. They have to have the same base. If they have the same base, I can add the exponents. So an example is if I have x to the third times x to the fifth, add the exponents, we get x to the eighth. The second way we multiply exponents is when we have parentheses. So anything in parentheses to a power already, the exponents will multiply. The old one and the new one multiplied together gives you the exponent that it should be. But remember, when you're doing it, those exponents are going to distribute. So everything in the parentheses will get that exponent. Coefficients, all variables, everything. So we have to raise to the fourth power the 2, and then you multiply the exponents for the variable. Okay? Let's do some examples. So, example 1. Which case is this? Am I going to add my exponents or multiply them? When I look at it, I see parentheses. But is there an exponent outside the parentheses? No. So I'm just adding. Okay, so I'm just doing the 5 plus the 6. What would we get? That's right, 11. So we would do 2 to the 11th power. Now that's not one I have memorized. So 2 to the 11th power is 2048. Again, if you have numbers and you can get a specific answer, plug it in and get that. If you have variables, you can't. Okay, example 2. I have a to the fourth, b to the fifth, and a squared. Okay, so I add them, 4, 5, and 2, right? Close. I can only add it if it's the same base. So I'm only adding the 4 and the 2. So I would get a, 4 plus 2 is 6. Well, what do we do with the b? We just drop it down, b to the fifth. We cannot plug that in the calculator. We don't know what values are stored for a and b, and it's going to give you a number, but it'll change from calculator to calculator, okay? Example 3. Are we adding the exponents or multiplying? Well, here we're doing individual multiplication. I don't see parentheses with an exponent on the outside. So we're going to add them. Well, what's the exponent of the last x? It's a 1. All of the bases match, so we can add them together. Now this is where it gets a little crazy for some folks, right? Well, it's just combined like terms. m minus 2 plus m plus 2 plus 1, right? M's, I have 2 m's. I have negative 2 plus 2 plus 1. So it's just plus 1. You put the x really big, and there's your exponent, 2m plus 1. I know, it's crazy, but we simplify them for a reason, all right? And we simplify them so we don't have to program that into computers and spreadsheets. We don't want to program the big one. We want to program the little one. Okay, now we have what? Yeah, this one's going to multiply. Notice the base of the 3 is that parenthesis, so it goes inside distributes. Well, there's only one thing in there. That's the 7. And it multiplies with the exponent. So, yeah, 7 to the 12th power. I bet that is a huge number. A huge number. Oh, yes. We got an e to the 10th. Okay, so it's like 1.38 blah, 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 blah. E to the 10th. All right. That means there's 10 zeros. We got to move that decimal place to the right. 10 of them. Boom. It's a big number. All right, so you could leave that as 7 to the 12th, or you can go ahead and multiply it out. All right, number 5. It's a multiply, right? Well, we knew that. That's what the whole thing's about. This one is outside. It's going to distribute and multiply. What's the exponent of negative 3? Well, it's just a 1. Okay, so let me do an in-between step. I would have negative 3 squared. The x has a 1 in there, so it would become 1 times 2, which is just 2. So we square the negative with the 3, and we would get what? 9. So it's a positive 9 with an x squared. If the negative had been outside the parentheses, we would not square the negative, okay? You'd only square what's inside. So differentiate, maybe add some parentheses in there so you remember, hey, I'm supposed to square a negative 3, not square the 3 and tack the negative on in the front. All right, example 6. I have parentheses to a power. Parentheses to a power, multiply the powers. That's why we do that little chant, all right? So when we multiply, what do? It turns. We add the powers. Parentheses to a power, we're Wonder Woman. We multiply the powers, okay? So now what are we going to get here? A, this would be 6 times 3, and B would be 1 times 3, right? So A is to the 18th, and B is cubed. There you go. In these examples, we're combining both of the multiplication rules. So sometimes you'll need to add the exponents, and sometimes you'll need to multiply them. And that's when students get mixed up and do crazy stuff. Okay, let's look at number 7. I'm going to look first for any kind of exponent that's outside the parentheses, something I need to distribute, because based on PEMDAS, that's the first step. I see I have a 7 outside the parentheses, so I know that I need to distribute that 7 inside with the x. So that's going to give me what? 2 times 7 is 14. So I now have x to the 14th times x to the 5th. Now we just have a multiply and we add the powers. So when we add 14 and 5, you get 19. So the correct answer would be x to the 19th. Let's try again. On problem 8, first set of parentheses, there's no exponent outside. Okay, so go to the second set. There's an exponent. So I need to take that exponent and distribute it to everything inside. My first set of parentheses is going to stay the same. So I'm just going to write it down. So I have the negative 2 x cubed y squared. It's by itself. Now, square the negative 3. What do we get? 9. The numbers are easy. The x, 2 times 2 is 4, and y would have a 2. Okay? That's easy enough. So the coefficients out front, do they still multiply? Yes, they do. All your coefficients are going to multiply. So coefficients, just plain old numbers, they follow the same rules they've always followed. Negative 2 times 9 is still negative 18. That has not changed. But now let's look. X's. I have 3 plus 4. 3 plus 4 is 7. So we get x to the 7th. For y's, it would be 2 plus 2, which is 4. So this would be the simplified algebraic expression there. All right, let's look at number 9. Again, look first for a number outside parentheses. I have a 6. It's going to distribute to everything inside. Write down everything else just like it is. That r at the beginning doesn't have an exponent, so I'm going to put a 1 in there just to remind myself. 6 times 3 is 18. And then I have an r to the 8th. Now I have a straight multiply. And when you multiply, you add the powers. Plus sign, plus sign. So 1 plus 18 plus 8. 27. So r is raised to the 27th power. That's going to be a big number. I guess it depends on what r is. All right, number 10. What have we got? First set of parentheses has an exponent. I need to distribute that. The negative sign is treated separately from variables. Think of it as a coefficient of -1. So I'm going to do the -1 and then do the variable. Okay? So -1 cubed is still -1. So I still have a negative sign. All right? What would I do? 2 times 3 or 2 plus 3? Yeah, parentheses to a power, multiply the power. So that becomes a to the 6th. Okay, let's look at the second one. We have a 2 outside. Well, we got both of them. All right. So the 2, again, negative sign is treated separate from the variables. Okay, negative squared. Remember, evens cancel, odd keeps the sign. So it's going to be a positive, and then what are we going to have inside? Yep, 2 times 3 is still 6. Okay, so these two are multiplying. What are we going to do with our exponents? We're going to add the exponents. What do we do with the negative out front? He's just going to stay there, right? Negative times positive is a negative. We have an A. 6 plus 6 is 12. Easy enough. All right? Let's look at example 11. First set of parentheses has an exponent. We need to distribute that. The 2, the x, the y, and the z. All of them are going to get the cube. Okay? So 2 cubed is 8. X, multiply your powers, parentheses to a power, multiply the powers. 6, y, 3, z, 3 times 4 is 12. Okay. Second set of parentheses doesn't have an exponent outside, so I'm just going to write it down. 6x to the 7th, y to the 5th, z. What's that z? What's the exponent there? It's a 1. I'm just going to scribble that in so I know. Okay, so now it's back to regular old math, right? We're going to add our exponents for those things that have the same base and multiply coefficients, all right? So 8 times 6 is 48. X to 6, x to 7. Add. 6 plus 7 is 13. Y cubed, y to the 5th. 3 plus 5 is 8. Z12, Z1. Yep, 13. There we go. 48, x to the 13th, y to the 8th, z to the 13th. Crazy, but correct. All right? Last one. Not last one. We got 2 more after this. Okay. I got a 3 outside. So I have to distribute it to everything inside. I can already see I'm going to have to distribute on the second one too. 2 things to distribute. That's okay. We can do that. So we got to cube the 3. Okay, so we got to cube the 3 and square the 2. 3 cubed is 27. And 2 squared is 4. Now notice I went ahead and added my exponents. So I multiplied. 2 times 3 is 6. 4 times 2 is 8. Have I added them yet? No. We're getting there. 27 times 4. What is 27 times 4? 108. Okay? And then 6 plus 8 is 14. All right? That's the simplified algebraic expression. 13. I have a quantity outside parentheses being distributed. Nice trinomial. Nice monomial. No exponent to distribute. Well, that's good. So we're just going to take this whole term and distribute it to everything inside the parentheses. We've been doing this for a while. Remember, we can only combine exponents for bases that are alike. We've been doing that for a while too. Okay, so negative 2 times 3 is negative 6. 1a and 2 a's makes 3 a's. Tack on the b squared. Not a big deal. Okay. Negative 2 and negative 2, positive 4. 2 a's, so it becomes a squared. 2 b's, 1 b gives me 3 b's. Easy enough. Negative 2, positive 5. Multiply, get negative 10. Oh, there's no a, so we just write that one down. B squared and b squared, 2 plus 2 is 4. Super easy. All we did was combine the GCF back in. Not a big deal. Example 14 is the one that most kids or students have fits with, right? Why is that? Yeah, there's fractions. It's those rational exponents again. I thought they went away with that lesson, right? No, they didn't. Okay, what are we doing here? When you multiply, you add the powers, okay? So these two exponents need to be added inside. I can add them because the bases are the same. All right, so now I have to stop and think. How do you add fractions? How do we do that? They have to have the same what? Denominator. Okay, do these have the same denominator? Yes, awesome. So I'm going to take 13 over 7 and add 8 over 7. What is that going to give me? 21 over 7. Okay? Can I reduce the fraction? Yes. That's awesome. That's 3. Okay, so what this really is, inside parentheses, is an x cubed. Now, remember that 4 that was on the outside? Yeah, we got to write him down. Don't forget about it. He'll cry. You leave him out. Okay, so we got the 4 on the outside. Now we can distribute that 4. Now, parentheses to a power, what do we do? Multiply. Multiply the powers. 3 times 4 is 12. Okay? So if I have the same variable, same base, I can go ahead and add those exponents and simplify the inside. If I don't have the exact same variable inside, so I can't add them together, they're not like terms, then we go ahead and distribute. This concludes all of the notes for multiplying exponents.